All right, so hopefully everyone can see that. So I do have a bit of a presentation tonight, but really want to touch on the Center for Geospatial Solutions, which is the new organization that I joined back in June at the Lincoln Institute of Land Policy. As some of you know, John C. Lincoln actually started Lincoln Electric in the Cleveland area. So again, more history with that. But it's a really great opportunity for me to work with some other colleagues that are huge names in the GIS and conservation field to be able to really build out new solutions, new applications, new technologies to help improve restoration and conservation design for organizations of all sizes and abilities. At our core, what we want to do is help our partners ask the right questions about where in the landscape should I work, what should I be doing, and make sure that they have access to the right data and the right analyses to be able to derive actionable insights. Where should I go on the ground? And to really make technology fade into the background as much as possible. Let us handle those details. Technology and GIS at its core, hopefully everyone has at least a base understanding of what it is, but it's a suite of different tools that allow you to organize, understand, and communicate information about the world around you. Everything has an aspect of place. And for those of you who spend time outside, you know, every place isn't the same. And what we really want to do is help our partners understand the landscape around them better. And it's not to say it's a replacement for just that gut feeling and knowledge that you have after decades of working out in the field. But what we're trying to do is help provide an understanding of what you haven't seen yet or where you haven't been yet, so you can really evaluate everything across the board. Major challenges that we're working to address are just access to the right data. As simple as that seems, the vast majority of organizations don't have the data they need to be able to address the challenges that they want to address. And so we're really making sure that they have access to that, helping with new different data generation tasks, but also really making sure that they know how to do the analysis correctly, you know, how to transform that raw data into those insights. As Roy mentioned, we are doing a lot around kind of the overused term big data. But more and more data is coming in that just has a fantastic amount of information, but knowing how to sift through that to find those kind of nuggets of what's really important is difficult. And for almost, I'd probably say 95% of environmental organizations, it's beyond their internal capacity to be able to handle that volume of data and know what to do with it. So we're really working on creating those workflows, creating those models that just incorporate it and make it much more accessible. Like I said, at our core of what we're trying to do is turning data into actionable information and empowering our partners with that to be able to make better informed decisions about where to work and what to do. Now, before I dive into some of the more specifics and examples, really, you know, one of my personal goals is to help transform the way we think about environmental management from measuring effort as an indicator of success. Oftentimes we talk about how many acres are restored or how many stream miles are restored, but that assumes that everything is the same. And what we're seeing is with access to new high resolution data sets and new analysis techniques, we can move from measuring 2 acres, you know, to these 2 hypothetical projects next to each other to understanding what on the landscape those projects are actually treating. You know, how much is flowing into that from a pure acreage standpoint, but also what's coming off that landscape to be able to say this project actually delivers more benefit than another. So we can focus our limited time and effort on the projects that are going to have the biggest bang for their buck. Now, when we look at it from an urban landscape in particular, you know, a lot of the models that have been used for watershed scale planning don't translate well to be able to identify specific projects or evaluate specific projects or to work in an urban landscape. Now, as Roy said, a lot of the work that I did at the Chesapeake Conservancy was focused in the Chesapeake Bay watershed. You know, I worked there for the last 8 years building the Conservancy's Conservation Innovation Center. And this is an example of downtown Washington, D.C. D.C. is facing a lot of similar issues to Cleveland in terms of combined sewer outflows. As Tori was saying, a lot of impervious surfaces where you just have that rush of water coming in, and they're actually using a lot of the same methods to be able to reduce stormwater in terms of bioswales and infiltration basins and other tactics. where we were working with them to be able to identify at a fine scale, where should those go? Now, when you look at the map on the right, you can say, yeah, this might get us close enough, but it really doesn't have the level of detail you need to be able to identify those specific projects. So the way that these models have currently worked is kind of say, okay, focus on this watershed and then hand it off to local implementers to be able to use their expertise, their knowledge of the landscape to say, okay, this is where we should be working, which works. You know, and it's not to say that it doesn't, but it may not be the most efficient system long-term to be able to evaluate everything across the landscape. So what we did in the Chesapeake and what we're looking to do in the Great Lakes as well is creating new high resolution data. So the previous image, each pixel, you know, each square in that image represented about a quarter acre on the ground. And that's what most data used for modeling is. That's the finest detail that it can get. And it just says this is low intensity urban development. What the new data that we created is 1 meter resolution. So that has 900 times the amount of detail. And our accuracy went from about 78 to 80% to above 90, you know, close to 95% accuracy. So we can actually be able to see where are the sidewalks, where are the driveways, where are individual trees in someone's backyard, and be able to incorporate all of that information into our models to be able to really drive down and be able to say, this is exactly where we should be working. It works in an urban landscape, you know, understanding the issues in Lake Erie as well. It also works in rural landscapes and agricultural landscapes. And that's honestly where we've done the majority of our work, is in a more rural landscape, but we do have a number of models working in an urban landscape. One other piece, just really quickly, aside from the land cover, is new tools for modeling streams. And this is just an example of kind of how the USGS classifies streams in the past, and new data sets that are much more accurate, both in terms of matching exactly where that stream is going, but also going from a one-dimensional stream center line to a 2- or 3-dimensional data set that actually gets bank to bank and bank height, which is really, really important for understanding where you have erosion issues and where you have those opportunities for restoration that Tori highlighted through the different proposals that Doan Brook Watershed Partnership is undertaking. Then what we can do, which is really gets really fun, is where we can take those land cover data, the hydrology data, you know, the stream data, and be able to understand where you have opportunities for restoration. Now, like I said, this is an example of a more rural agricultural landscape, but this is where you could do riparian buffer planting. So stream-side tree plantings to have its greatest impact. And you can see this is one property, but we can actually do that across an entire landscape. So this is a 4-county region in Pennsylvania where we analyzed and prioritized every single parcel across that. You know, and what we did is we took it from about 8,000 potential parcels that had high quality opportunities, prioritized them based on about 40 different characteristics to be able to narrow in and say, here's our tier 1, our top tier properties, which are 278. So we're taking that just sea of opportunity and helping to focus in and be able to say, okay, here's exactly where we should be focusing. And I won't go into too much technical detail on it, but you can kind of see on the chart on the right, you have a designation score, which is based on, is this on a high quality stream or in an impaired watershed? And then the total score also combines in those site characteristics. And what you can see is projects like this one over here, which has an extremely high score, higher than a lot of the top tier designation score projects. That is a otherwise, you know, unmentionable stream, you know, just it's not spectacular, but because it has such high quality of that score, people should be focusing on this. And if they only focus on those target watersheds that the traditional modeling does, these types of projects are just going to be missed, where you have that really high impact opportunity in an area that you otherwise wouldn't be looking. Now, it's not just about the scientific professionals, though. A lot of what we're also working on is how do we engage with the general public. So the same data set that I just showed with that prioritization, we actually built a public-facing tool as well, where you can actually go in, type in your address, and get a customized report about your property showing what is the restoration opportunity, what are the benefits of stream-side planting. And one of the really cool aspects of this is we actually reached out to local restoration professionals to say, tell us the types of projects that you're interested in, whether it's what zip code you work in, or a minimum size, or a maximum size, or whatever it was, and actually played matchmaker on the back end. So the last page of this report is actually a list, a contact list of restoration professionals who we know are interested in doing a project on your property. Where we want to go from here is to be able to engage with the donors and the foundations as well to really greenlight projects that meet criteria for them. So it's as easy as possible for someone who wants to do the right thing to say, okay, I found this opportunity, sign me up. And someone shows up on the doorstep, it's already paid for through a foundation, you have the restoration professional lined up, and really streamlines that process. As Roy and I have been talking about opportunities within the Central Lake Erie Basin, we really see a lot of opportunity with some of the tools I'm going to start to highlight a little bit later in the presentation for things like rain barrels and what you're talking about, or the stormwater consultations, where it makes it just really easy for people to go in, see what the opportunity on their property is, and then hit that contact me button. And it just fires off an email to the right person and has someone reach out because you know that person's interested. The way I look at it is every time someone has to make a decision about, do I really want to do this, you probably lose 50% of respondents, potential respondents who may be interested. So if you look at it from, I have to click this button, I have to click that button, or I have to take a step of calling someone myself, you start to lose people who would be interested but just really aren't as interested to be able to go down those extra steps, which isn't the best thing to say, but the goal is to make it as easy as possible to get people engaged and to bring them into your projects and have those projects actually completed. Other efforts that we're working on are things like the Water Data Collaborative. This is a group of 5 leading community science NGO water quality organizations: Isaac Walton League of America, Waterkeeper Alliance, River Network, the Commons, and the Chesapeake Conservancy, where I used to work, where we're working on empowering groups like yours to be able to do streamlined field data collection, be able to improve data management, and then really create visualization and communication tools off of that to make it as powerful as possible and as easy as possible. Now, as I said, it's not all about the agricultural side, especially when you come into urban landscapes like Cleveland, where you do have a lot of issues. And this is where the power of the data, and as Roy was saying, precision conservation, really comes into play, because you have a level of detail where you can hone in and actually understand at a very specific landscape what's going on. So this is an example from Washington, D.C., where we worked with the District Department of Transportation to help identify stormwater inlets and prioritize stormwater inlets, because they have large-scale projects similar to Cleveland to drill giant tunnels under the city to capture stormwater so it can be treated over time, as opposed to going through CSOs and actually dumping raw sewage. And so what we did is looked at every single storm drain across the district and leveraged the land cover data and high resolution flow information to understand where and what projects should they start to be doing first. And just as a baseline to remind you where we came from, this is the previous data zoomed in at that neighborhood level. And you can see it's just useless. You can see big red blocks and it doesn't really mean anything to you. But when you look at the high resolution data, you can start to see exactly where you have buildings which are in red. You can see the roads which are black. Light green is low vegetation like grass. Dark green and yellow are tree canopy. And we're actually looking at both tree canopy over roads and other impervious surfaces versus just straight tree canopy, because that actually interacts differently with the environment. And we can model both ways on that side. So we can take the high resolution tree canopy, or the high resolution land cover, and then we can look at how water moves across the landscape. And this is produced using LiDAR elevation data, which is a really high resolution elevation product, basically collected by bouncing a laser off from a plane off the ground and measuring how long it takes to come back. And then you can locate that in 3D space and turn that into a variety of products. But what you can do in these, hyper colorful lines is basically showing how all of the water is moving across the landscape to get to this star, which is a stormwater inlet. And then you can map out all of the blue area as everything coming to that. And then you can actually look at the land cover in conjunction with that, combine annual precipitation data from different models to be able to say, for this inlet, how much water do we expect it to be treating? So if we were to put a bioswale in, or a retention basin that has a 40% reduction efficiency, you can actually get down to how many gallons am I going to stop from getting into the sewer during a different event. And that's really powerful information to be able to prioritize across the entirety of Washington, D.C. What projects should I do first, then second, then third, then fourth, to have the biggest impact for the dollars that I have. Now, bringing it a little bit closer to home, I wanted to show an example of just something that I was able to put together over the last week or two, leveraging existing data from the Cleveland area. So this is taking a look at Shaker Heights. And we're going to take a look at how that similar technology to what I just showed can really operate and work in the Cleveland area. And one of the things I'll preface this by saying is this is using LiDAR data that's a couple years old. In Ohio, coastal, Lake Erie, Ohio is actually having new extremely high resolution LiDAR flown and delivered over the next year, which is going to be able to take even what I'm showing you today to a whole new level. I'm really excited to have that coverage. But this is neighborhood. You can kind of see the different shading colors. This is just the elevation underneath, how that lends itself to water moving and really using the streets as a main conveyance from when water hits the ground, flows off your yard down to the street, and then along the street to the nearest storm drain. And what you can start to see is when you overlay properties and property boundaries and houses, you can see what that might make a little bit more sense of what this is and what this looks like. But what we can actually do is begin to identify where on a property you have the highest amount of accumulated water coming off that property, and then delineate kind of the micro watershed at a property level coming off of that. So you can see for every single one of these properties, the blue dots is basically showing, the top of the blue dot is where you have the highest amount of flow, and then you have the watershed kind of coming back. And for some of these, like this property up here, all of these 3, 4 properties are really draining through that one property in that one place. And that starts to become important as the example that Tori showed earlier, where that flooding probably wasn't the result of one property. It was probably the result of 5, 6, 7 properties all coming down to that one point untreated. Where it also gets bigger down here, you can start to see this whole network of watersheds is all coming down through this one property. And that's where you really start to have issues, but you can also start to address them. And back to kind of the point that Tori made in terms of you have fantastic resources in place to be able to do these consultations and to be able to help people understand what can they do on their property. But in a lot of ways, it's a reactive process. Someone needs to call you and be able to say, hey, I am having issues, would you come out? So they have to know about you. They have to take the initiative to call you. And there's a lot of steps where you lose that interested public. With maps like these, what you can do is you can prioritize, and you can start to say, where are the biggest opportunities to have an impact? And you could do things, some of our partners do mailings, where they just take the top 200 potential projects and they just send a postcard to those addresses, and they say, we are here, this is a free service, we want you to know it's here, and just have that response. And that's a fairly low lift, low effort way to increase the number of people, important people, who are reaching out to you and having those conversations. If you want to, you can also knock on doors, and that's another really good way to be able to prioritize that and be able to, maybe not in COVID, but be able to have an opportunity to drive new partners coming in. Another example, and this is moving south a little bit on a larger scale project, this is the Canterbury Golf Club. And when you look at it from this perspective, you can see 1/2 to 2/3 of the golf club is all draining through kind of a single network. And you can start to see how you go through some of the water traps, and you can start to see how it's going along some cart paths. But it really comes in, and if you look at Google, if you're familiar with it, you can see kind of the channels coming down. Now, looking at it, and this is about 25, 30 acres of land all draining through that point, you start to understand a little bit of like, okay, there's a lot of water, especially when it rains. Golf courses aren't necessarily I don't know Canterbury well enough to say what they're doing in terms of practices, but lots of times when you have a lot of green grass, there may be excess nutrients and fertilizer and other pesticides and issues coming down all through that one place. When you look at this blue dot, and I just went to Google Maps and look at from that, this is what it looks like when it's exiting the property. It is a small, probably 12-inch diameter pipe draining 35 acres coming through that. And this is an opportunity where you can do things like a small wetland restoration project, figure out what works for the golf club. But you can start to have those really outsized impacts by focusing exactly where you need to be able to treat all of that upland area. Now, I talk fast and I had a lot of information, but what's next is really Roy and I are working to identify some of those core challenges and potential use cases. as I said in the beginning, what we're focused on is making sure our partners have the right information and the right tools to be able to answer the core questions to what they're trying to do as an organization. And we really want to explore the different partners around the Central Lake Erie Basin. What are their challenges and how can this data help address that? We're also looking to complete a couple of regional pilots, because a lot of this, you have to see it to really understand it, and to be able to get some of that core data analysis done and really start to build that interest and groundswell for having the new tools available to be able to really refine our understanding of the landscape. And then finally, similar to events like tonight, is building our partners' understanding of the data and how it can be used. One of my favorite aspects of my job is just having conversations with people after they see a presentation like this and say, well, I've got this challenge, could you help me with that? And thinking through how you can actually build some of those analyses and those different data tools to be able to address challenges and really make a substantive difference in how people work on a day-to-day basis. Well, I really appreciate the time tonight. This is my contact information, and I really encourage anyone who wants to talk more or just learn more. I always love a good conversation. I believe we have some time for questions now as well, unless I went way over time. But from there, would definitely appreciate the time tonight, and would love to answer some questions if you have time.